But I hope what you've gotten from this as well is not like tooting our own horn thing, but a little bit of an appreciation for how complex and hard it is to do research. To publish in these journals, we have publication fees of about $3,500 just to publish the paper. That's it, just to publish the paper, not to think about the hundreds of thousands that it's taken to actually do the research. Next study. I really like this one. The specificity study. How many times have you heard, subluxation is not a thing, you don't need to look at it, maybe we'll manipulate them where they hurt, maybe we won't even do that. I'm not going to be mean, I don't want to be that person. But there is definitely been questions of us of, does it matter where you adjust? Are you adjusting just any old segment, or are you adjusting a subluxated segment? Of course, everyone in this room is going to say, yes, it matters. But guess what? We had to do the research on it. So we did 96 adults with subluxations. And we use the activator because it's a really precise tool that we can use for this. And we either put that activator thrust on a subluxated segment, or we did it to a non-subluxated segment. This had some interesting philosophical discussions amongst the research team of, is it actually okay to do this to our participants? But we kind of were like, for the name of science, yes. So we measured how the brain was responding to this. So EEG and something called SEPs, which is somatosensory evoked potentials. You're never going to want to remember those words, but essentially it is, how is the brain responding to what's happening inside the body? And the results of this, no surprises, but the adjustment to the subluxated segment showed significant changes in the brain, and to the non-subluxated segment, essentially nothing happened. There was no significant changes to the brain. Just sit on that for a minute. It actually really matters. You have that subluxation analysis done properly. You are adjusting subluxations. That is what changes the brain, not any old thing like whacking someone with a stick. Okay? It is your adjustment, the precision, the art of that, which is making those changes for people. Another scanny if you want to. I'm also really happy to send these slides to everyone, because I get that probably half of you have fallen asleep by now, or at least you've gone into your default mode network and are no longer paying attention. It's a lot, I know, for the end of the day. Oh my gosh. This study though, oh, okay, I don't know why I saved this for last, because it's a lot. The biomarkers study. We wanted to definitively measure what happens with the neuroimmune system, okay, when someone is under chiropractic care. And this came out of the COVID nonsense, where we really were very certain that people would be better off if they were getting adjusted, but there was no evidence to show that chiropractic care actually affects the immune system. No hard, strong evidence. So we did a clinical trial, 12 weeks of chiropractic versus what we call sham care, which is pretending to adjust someone. That's quite hard to do. This research was done in Pakistan, and I just have to say something on that because it does matter. In Pakistan, there is I don't think there's any chiropractors, or there's very, very, very little of it. So these are people that have no idea what an adjustment is and what it feels like and what it looks like. So we're going into what we call a chiropractic naive population. And what we did is we tested at the end of the study, did you think you were in the control group or the chiropractic group? And they had no idea. And so this is our attempt at successful blinding of the participants. So they didn't know if they were getting adjusted or not, and in research that matters. We did some blood tests on these people. One of the markers we were looking at is a very well documented blood marker of neuroplasticity. Okay, BDNF, brain-derived neurotrophic factor. This is not chiropractic stuff. This is like neuroscience, BDNF. So we were measuring that. We also measured cortisol, and we have measured the inflammatory markers. And I tell you, when they got the results of this, they were like, oh my God, what do we do how do we make sense of this? And I'll explain why. So first of all, amazing to see BDNF, the neuroplasticity marker, shot up in the chiropractic group and did not change much at all in the control group. So we have hard evidence we are creating neuroplastic changes in the brain. Okay, BDNF. It is a really crucial marker. It helps to control neuronal health, growth, adaptation. Pretty cool stuff. And then we got the cortisol and the inflammatory markers. Cortisol. In the chiropractic group, we did 3 different types of cortisol in the whole study: salivary, blood, and hair. And that is because cortisol is really different if you're measuring it acutely versus chronically. In the chiropractic group, the salivary cortisol, which is kind of like an acute thing, went up. Okay, overall it went up, and we were like, oh my God, cortisol is bad, isn't it? Cortisol, stress hormone. Oh my God, we're stressing our people out. But when you actually know a lot about cortisol, and we had to do lots of reading about this and digging into it and getting advice. Cortisol, yes, it's a stress hormone, but it often is in place when the body is kind of coping with things and receiving input. There's a bit of inflammation. And what are we doing to those muscles? Okay, when you put an adjustment in and you are stretching those muscles, you're irritating them a little bit. Okay, I like to think of it like when you go to the gym and you work out a muscle, that's what we're doing. And so there is a bit of like, we are making them work, and it's causing a little bit of a stress response in the body, but not a bad stress response. This is adaptive stress. Then we had the inflammatory markers, and we found that interleukin 6, which is a pro-inflammatory marker, went up in the chiropractic group. But the other markers, TNF alpha and interferon gamma, went down. And we're like, okay, what the hell does this mean? It turns out that interleukin 6 has another role, and it is a myokine. And a myokine is a chemical mediator in the body which induces muscle change. And it's like the body is changing those muscles and healing and working those muscles. And we know that this was acting as a myokine because the other inflammatory markers went down.